Very good morning. Assalamualaikum and very good morning to all of you. All students, any lecturers? Ada lecturer kah?
Supposed to be si Muhammad Alif tuh, Encik Muhammad Alif.
Okay, so we have quite a few PhD students, which is good. Master by research, and most of them are MBA or MSCM students. So I'm not sure whether every one of you already know or not. The workshop actually consists of 3 series. Series 1, 2, and 3. This morning, we're just gonna talk about introductions to partial least square, that is PLS, just introductions. There is no hands-on, no calculation, no activities of engaging with PLS. Okay, most likely we will use Smart PLS and SPSS PLS. The rest, I don't have the software. Okay, but I think most of you will most likely engage with Smart PLS. All right. Okay. So what is everybody okay?
Yes.
Can hear me clear?
Okay, Dok.
Sorry,
If,
Doctor.
yeah.
Okay, Doctor.
I hear 2 voices, Doctor. It's like ada buzzing.
All right. Okay. All right. Okay. Okay now?
Okay, Doctor. Perfect.
Perfect, huh? Okay, I will use the laptop when I need to draw some things. Yeah. All right, so intro to PLS. So what is PLS? PLS is a SAM. Huh? I think all of you are fully aware. It is structural equation modeling. We have 2. That's the most common one. Okay, the covariant base and the variant base. The CB SAM, in a short form, we call them CB SAM or PLS SAM. As I proceed with my slide, if anything goes wrong, say because I can't see your face, but if anything goes wrong, you don't see my slide and so on, feel free to just interrupt me. Yeah. Hello.
Yes, Doctor.
Okay, you need to participate. Don't just keep quiet.
Okay, Doctor.
All right. Okay.
Okay, Doc.
So I'm gonna go through a very brief first about what is SAM. Get to know what is SAM first, okay? So that you get some idea behind it, the fundamentals of SAM. All right, we have 2. That is the covariant base and the variant base. For our workshop, we talk about the variant base SAM. The covariant based one are, maybe some of you have heard MS, Listrel. Okay, these are covariant based SAM. Okay, the 2 are very different. Okay, CB-SAM is a parametrics approach. Variant based, the PLS is a non-parametrics. Maybe some of you don't know what is parametrics, non-parametric, but we'll cover that things in the second series. What is parametrics? What is non-parametrics? Okay, but for the time being, for this morning, get some fundamentals first. Okay, but before we go to the SAM, I will talk about the SPSS. What is SPSS? Some of you have engaged with SPSS before, okay, but some of you probably never engaged. All right, SPSS, as you're probably aware or know, it has been around for many years. Okay, it is the first generation of techniques. Okay, statistical package for the social science. Okay, basically it's a regression-based approaches. Okay, you have heard about multiple regression analysis, discriminants, logistics. factor analysis. These are all under the first generations, okay, which they're quite common in SPSS software. Nevertheless, SPSS, before SAM came into the picture, most researchers, they have no choice but to only use SPSS. But we know that SPSS has some limitations. Most of the common limitation of SPSS is that it just can't perform simultaneous analysis. Basically, that is the limitations. So what it says that, okay, it says like this, okay, you all can see here,
Yes.
all right. So here is your independent variables, okay. Come on, acknowledge something. That is your independent variables. Usually on the right side, you'll always be your DV, your dependent variables. Okay, and each of these dimension or construct, sometimes we call it construct. In SPSS, we call it dimension or constructs. In SAM, sometimes we call it latent variables. Okay, latent variable is something that you unobservable variable, but you create on your own, which represent what is it that you want to measure, and we call it latent variables. But in SPSS, it is quite common that we call this dimensions, constructs, variables. These are some of the terms that we use quite commonly. And each of these variables or dimensions, okay, they have some items. Sometimes we call it items, sometimes we call it indicators, sometimes we call it measures, depending on which literature that you refer to. Basically, it is the questionnaire that actually measuring the variables. So in SPSS, okay, if you want to regress, okay, either one or combination of this discriminant analysis or factor analysis or multiple regressions, okay, you can't, if you want to regress them individually, you don't have this. You can't specify this in SPSS. You need to input all these items into SPSS and then regress into the dependent variables. So that is the setback. So oftentimes, most researchers, they collapse all these items into one, represent this, the variables. You get it so far?
Yes, doctor.
Okay. So these are very fundamental, only SPSS. Okay, you need to know about the reason behind why we're actually using SAM, especially those PhD students, because under the methodology chapters, some of you, or if not all, you need to provide justification why you actually use SAM. Why didn't you use SPSS? Why you use MS or covariant SAM approach rather than the variant ones? You need to explain. You need to give them justification. So that's the reason why I need to explain, get some idea what's the reason behind it, how actually this SPSS work, why SPSS has limitations. Okay, so this is basically what the limitation is. All of you have attend Dr. Jude or Dr. Lim or Inche Rosley or Dr. Saizal SPSS interactive class, isn't it? Right? Especially MBA and MSCM students.
Yeah, doctor.
Yeah. So I believe you have gone through this process. I'm not sure about the PhD student or the master by research student, whether you have attended some research methodology classes. Come on, interact with me. Don't be afraid. Don't be shy. PhD student, Master by Research student, acknowledge to me, have you actually gone through this? Are you familiar with this? Don't worry, even if you're not familiar, I mean, that's the reason why you are here, isn't it? So don't be afraid, don't be shy. I need to know this because if later on, once I goes to at the later stage, okay, say for example, on here, 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 okay, it will start to become very technical. So it is good that you follow me. You are always next to me during my presentation or during my workshop. How is it so far?
So far, okay, Doc.
Okay. So this is what I'm trying to share with you. You need to know the fundamental behind it. Because there are quite a number of students when they go to their supervisor or when they present, there seems like not aware of the reason behind it. They only know how to operate the technicalities of running the analysis via SPSS or Smart PLS or MS, but they do not know the reason behind it. And you need to know, especially those PhD students and master by research. MBA, MSCM, all right. Because of the time limitations that are limited, we accept some of the looseness of your work. But for PhD and master by research, no. You need to know this. You need to know the reason behind it. So SPSS, if you were to run individually, you don't have this dimension. You are actually keying the individual questionnaire. Okay, and then each of these individual, they will have the coefficient number values. We call it beta values or coefficient values. And you'll be able to know which are the items here that have a strong prediction among themselves to or affect or influence the dependent variables. Or you collapse them. When I say they collapse them, you sum all these items, become one. Okay, it become one. Then you don't see the item anymore. And you don't know which one item that play a big role because it's already represent this. That is the limitation of SPSS. All right. Okay. Ada okay kah?
Okay, Dok.
Jangan cakap okay saja.
Okay, Dokter.
Okay. So I provide some reading materials here. If you want, these are some of the limitations of SPSS. I'm not going to go through in details because this workshop is not about SPSS. This workshop is about PLS. But before we talk about PLS, it is good that we get some ideas. What is the first generations of statistical package for social science? That is SPSS. What are the why before Sam came into the pictures? All those PhD students, old timers one, most of them are use SPSS or they use econometrics using equations. So they do have some limitations. When these limitations arise, the problems here is that the result will not be, you can't generalize the result because there's some errors, high errors sometimes. In other words, down here, the results are not completely correct. Okay, so that's the reason why Sam came into the pictures. When Sam came into the pictures, okay, it allowed spontaneous modeling of relationship among multiple independent and dependent constructs. Therefore, one no longer differentiate between dependent and independent variable, but it is using exogenous and endogenous. Exogenous are here, endogenous here. Usually endogenous are the dependent variables. Exogenous are the, not necessarily has to be the independent IV, but it can be mediating, it can be moderating as well. You see? Later on, when I proceed to the next few slides, okay, you will get some maybe a clear understandings. Now, what is it about? So, in SAM, earlier when I talk about SPS and in SPSS, you either collapse this or you regress them individually. Okay, you regress them, and this will be your hypothesis. You all see the arrow or not when I point? Because I can't. Yeah, you see my arrow, my cursor. You see?
Dapat, Dokter. Can.
Okay. So you have this. Your hypothesis will be here. Okay. In SPSS, okay, if you collapse them, you will represent this. You will represent this. So, for example, there's satisfaction. You represent satisfaction. But in SPSS, okay, if you don't collapse them, you need to regress them one by one. If you regress them one by one, there is no satisfaction appear in your output. It will only appear the list or the sentence of your questionnaire. Or you modify it in your SPSS, you make it into small terms. You can modify, you can manipulate in SPSS, but it only regress one by one. And this one, you need to regress another one, and then another one. So it become what they're saying here is that in reality, okay, in reality, all these dimensions come simultaneously. Say, for example, that when you, all right, now it's about nearly to 10:30. Some of you have not taken your breakfast. You all have taken your breakfast or not? Already. Some maybe take a little bit, some heavy breakfast, and then you don't feel like hungry anymore during lunchtime because you had your heavy breakfast. Some a little bit. Some not even have breakfast, just probably just coffee or just drink hot drinks. Later on, somewhere around 11 something, okay, your stomach start to make noise. Right? Is that true? I mean, generally, it's supposed to be naturally, it's supposed to be like that, isn't it? Hello?
Yeah, Doctor.
All right. I just want, the reason why I share with these things because I want to be interactive with you all. And then I want to use these examples that most humans or people, okay, they think not single variables. They think using multiple variables at one time. Some of you, in your mind, when you start to feel hungry, that you start to scan in your brain that what you want to eat, isn't it? What do you have in mind? And some of those variables that actually influence your mind is your past experience or something that pop up this morning. So it's not part of your experience, but it is something that you saw earlier and you feel like that's the one that you want to eat. So in other words, down here is people make decisions based on several factors at one time, not maybe not simultaneously, but within that radius of within 30 minutes, multiple factors come into effect that finally you make the decision what you want to eat. Do you know? Do you get it? So that is what they are arguing, the researchers in the past, that if you actually using SPSS, okay, you would just not able to regress multiple dimension or multiple factors that may influence your decision of what to eat, because you actually regressing one by one. You see? So in reality, it should not happen like that. In reality, it happens simultaneously. So independently, okay, SPSS still can be applied, because that's the reason why they call it independent variable. It doesn't interfere from one another, right? And it's still acceptable to regress them one by one. However, there are variables which we call it moderators, mediators, that actually mediate or moderate the relationship between IV or exogenous to endogenous or DV. You have that clear now? You do have some idea already now?
Yeah.
Do you understand?
Yes.
Okay. So you get that fundamentals. So when you actually presenting or try to do your research work, then some of the MBAs you probably already have your topics. Probably you have already come out your problem statements, isn't it? And most of the PhD students, they already know what are the topics. They already met with their supervisors. They discussed few times and so on, isn't it? But most of you are still in the process of reading. You see, your reading are still going on. And what they are I'm trying to share with you is that some of those variables, okay, you may want to consider them whether it is actually should be in your research model or not. You see, and that is the reason why most, if not all research has to be confined to one particular theory. And that theory actually guides you what variable should be in the theory and what should not be in the theory. You see? Say for examples, the theory of product life cycles. Product life cycle, we know for sure it has how many stages? How many stages?
4.
Hello? 4. We have 4, isn't it? What is the first one? Hello?
Introduction,
All right, good. Then?
growth, maturity, and declining.
Decline. So you have 4 stages. Of 4 stages, okay? So what we can do here is, we got 3. We can add another one down here. The 4 stages is for sure. Your examiners, external examiner will never question you anymore, because they knows that that's what the theory is. So they will not question you. You see? You understand? So your dependent variable will have 4, but you need to read more about the theory. Which stage they actually affect the product development? Okay, is it the first stage, second stage, third stage, or the fourth stage? That's the reason why later on when I show it to you, because the reason why I use this product my product life cycle, because all my example is actually about product development, and you'll be able to see. Okay, like this. It's a product development. And then we have idea generation, business, testing, and pre-marketing. It consists of, in my studies, it consists of 4 dimensions. Which are the dimensions that, the factors here play a huge role to which one of the stages? You see, you'll be able to detect them. Okay, we'll see the one later on. You see? Have some idea now? Okay. So this is another covariance. Okay, let's look at the covariance one. Basically, I'm not going to go through all in detail. This one you can read. Basically, what it says down here is covariance is that it's very similar to PLS. Okay, we have 2 factors here. These are all the questionnaires. You see? The difference between PLS and covariance is that it has a correlations error. Yeah. Okay, I'll give you another example. So, do you guys see it? Can you see this by Google? Okay, so confirmatory is okay. That's the reason why many students, okay, but for the PhD, if you actually use MS, these are MS. I'm not saying that MS are stronger than PLS, okay, but there are reasons to what I'll show. We'll talk about it later on. But what I'm saying here is that MS are much more rigid. It's a more of testing theories. So basically, the huge difference about PLS and CB-SEM, okay, PLS-SEM and CB-SEM is that CB-SEM require a robust and rigid confirmatory factor analysis before you actually go into the structural testing. So in other words, down here, the model has to be fit first. So how to get it fit? Okay. All this, this example is just a very simple one. I only use an examples of 2 variables, negative effect factors and hopelessness factors. This has to be correlated. If it's not correlated, okay, the correlation value should not be more than 0.7. If it's more than 0.7, then you will have a multiculinary issue. In other words, down here, these are the arrows. This arrow represents the questionnaire. You get it? You see? These are the questionnaire. And for this dimension, the questionnaires are here, the arrow. So what they are saying here is if its correlation is higher, meaning this and this has, it is actually not much different. Okay. The items also correlated to either one of them. And then that's the reason why you have higher correlation. When you have a higher correlation, that is a multiculinary issue. Multiculinary issue saying that some of the items here also can belong to either one of them. So there is no discriminant validity. You need to discriminant validity. In other words, down here, all the items that you are testing for negative factors has to be the correct measure to measure this. Of course, because we are using statistics, there are some figures indicating that some of the items here actually can belong, but as long as the value is not too high, it should be okay. And one thing good about MS is that you can correlate the error. You can actually correlate here using this to reduce the errors so that you can have a model fit. That is MS. Not sure whether some of you probably may not get it, but if you are doing your PhD and you intend to use covariant SAM, you have to know this. You have to. Okay. But again, this is CBSAM. Our workshop is not CBSAM, but it's just that to get some idea what is that about. All right. And then what they're saying, the objective of CBSAM here is to reproduce theoretical covariant metrics without focusing on explained variance. Explained variance is we are not looking on the independent variables. We are looking at the overall of them, whether they are theoretically related. That is what CBSAM is all about. Any questions so far? Are you with me?
Yes.
Yes.
Okay, so let's go on the PLSM. PLSM is much easier. To be frank with you, I would say it's easier. Okay, the objective is basically to maximize the explained variance. What does that mean? What are these are dimensions. All here they have some variance, and you want to know what is the influence, what is the predictions of individual here. Not so much about the theory itself, but the relationship to here, and relationship to here. And all these items, we also can ensure that they are actually belongs to these variables. That's the one thing good about PLSM. Okay. Under PLS, okay, we usually they fall either reflective or formative. Okay, so these are not examples. Timeliness, okay, these are reflective, these are formative. So basically what they're saying here is that if we go by timeliness, okay, there are three factors here, but I only give two examples, but Y1 and Y2, same thing. The three factors, I only give two examples. So what it says down here is that punctuality of meeting deadlines. If you want to have a good timeliness, make sure that you're punctual, you come to class on time, you don't come late. You always come late, then how do we actually force you to come on time? You see? And same thing, we have a central reservation system. In the hotel hospitality line, most hotels, they have a central reservation. To any customers, okay, I don't have to call the destination hotels. I can call the toll-free number of the central reservation system and do my reservations. And all those reservations will immediately transmitted to the destination hotel. Immediately. So I depends on. So it's a reflective. If you have good ICT, more likely there's a positive correlations to timeliness. Correct or not? Is that correct? Correct or not? No.
Betul.
Huh? Hotel locker. Are you all with me or not?
Yes.
Okay, so let's
Yeah.
say what about formative? Formative, okay? The variable is life stress or unhappiness. Okay. Stress. What causes stress? If you lost your job, you lost your loved one. When you lost your job, you are very unhappy. It links to unhappiness. You lost your loved one, it makes you very unhappy or they're stressed. But there are some people when they lost their loved one, they feel happy, isn't it?
Yes.
Oh, yeah. Yeah, so there is. But what about lost job? Is there anybody happy if you lost your job?
No.
No. See, this is what we call. So I purposely use here. Actually, here, if I quote from the original source, they put it here: divorce. Generally, okay, when you got divorced, you feel stress, isn't it? I mean, generally.
No experience.
Yeah, you don't have experience. Okay, of course. But what I'm saying is that, okay, if you look at here at the bottom, indicators can have positive, negative, or no correlation. So that's the reason why I said to you earlier. Under formative, if you get divorced, there are some people very happy because they want to get divorced for whatever reasons lah. You get it my point or not? You get it the theory or not?
Yes.
Okay, so the theory is like that. It's logic. You see, it is logic that sometimes divorce may not lead to unhappiness. Sometimes divorce may lead to, or it can form something. That's what the theory is. Okay. So is it a good example so that you can understand much easier? But these are very loose examples, but easier for you to understand. But in your studies, you need to build based on a strong theoretical foundation. You see, another example, the theory of supply and demand. You see, when there is short of supply, normally what happens to the price of the product? When there's a high demand, what we can do? We can increase the price, isn't it? And if the product is a necessity product, people will still buy with the expense of paying more, isn't it? It's the theory. That's the reason why we do have governments interfere and then they control certain prices that are not supposed to be manipulated by certain companies or people. So there's interventions of regulators. And that's what the theory is. Okay? Clear? Clear, isn't it?
Clear.
Ya ada respon juga ini apa macam ini. Okay, so this is the examples. So if you look at here for reflective, usually indicators must be highly correlated when it comes to reflective. But when it comes to formative, it can either be positive, negative, or no correlations. Then people want to test. We want to hypothesize them, see whether there is a positive or not positive, if they is accepted or rejected. And that's the reason why you engage into that kind of investigations. All right? Clear? Boleh kah?
Boleh, Dokter.
Okay. If you're not sure, these are fundamental because next week we are going to talk about the analysis, the regressions. That will be more on hands-on really. Most of the time that will be hands-on. So if you don't know the fundamentals, okay, it will be very difficult because you will easily get lost. You will easily get lost, especially those who have not engaged any statistical exercise, or those who have never been or never engaged at all. You see? But for those who have actually engaged, you have practiced, you will play with, I mean, use this PLS as your toy, something that you play with. You can plug in and then draw, pull the arrows and so on, and then test it, run it, and then run it, and then be able to see how do you actually generate the values. The value will talk, whatever come out from the output, okay, we'll talk that next week. Okay? Next week will be 3 hours. It will be longer because there will be lots of interactive presentation so that you guys be able to see how do you actually run the your regressions. And first, the measurement model first. How do you actually make the model fit first before you go into your structural testing? Okay, all right. So these are some of the reasons or advantage why you decided to use PLS. Okay, you can read here all this. Basically, what's good about PLS is that if you have a small samples, again, small samples, for me, not just because the PLS allow you to run with small samples, because the PLS using bootstrapping. In order for you to generate the t values, okay, and your standard errors, you need to bootstrap. Bootstrap, you can define up to 5,000 samples. You see, and then one thing good about PLS, even SPSS now, you can actually bootstrap. But PLS, they bootstrap to you, so they use the mechanisms of what is the possible patterns that they are able to generate based on your actual data. Say, for example, your actual doctor only up to 100 or less than 100. You use Bootstrap to up to 5,000 replication. So in other words, down here, it is like you actually have 5,000 data respondents. That's what Bootstrap is about. You see? And it allows you to do that. Okay? But that is statistics for non-parametrics, PLS. It allows you to do that. But we have in research, academic research, we do have this population and sampling size. Totally two. And then that's the whole we have G power. According to Hayes, okay, they have, it's correlate with your number of questionnaires. Ideally, the ratio should be 1 to 10. 1 to 10. But it allows you to go with a ratio of 1 to 5. So say, for example, that you have wait, I need to pick up my phone. Okay, so say, for example, that you have 50 questionnaires, right? And then you have to time 5. You see? That will be your base, right? Especially those who are doing PhD and by research. You have to abide this kind of parameters. You have to, unless your populations is limited. Some of you are doing companies. Your unit of analysis, not individual. Your unit of analysis are companies, organization. So your respondents, okay, are still the individual, but they represent the company, not their opinion, but the experience of engaging whatever decision making that they make on behalf of the company. So the answer actually is the company policy or the company strategies. So when you have a population of, when you have a unit analysis of organization, most likely your population will not be high. Say, for example, food service, fast food, you see, KFC, McDonald's. We have thousands of outlets across the countries, but they represent one entity of organization, that is KFC, McDonald's. So you go and approach the HQ. You don't go approach to the outlet. So even though the numbers of outlets are 1,000, but they represent one. You see? So the numbers of fast food population are far lesser compared to independent restaurants. You understand? Yeah. Right? So you got to be careful, huh? You got to be careful. If your populations, if you have a limitation of population like that, there's no choice. That's your population. Then let's repeat the ideal one for you. I'm not saying that will be the right choice, but it will be the ideal one. You see? So you're more likely you don't have a sample size. You go straight away to populations. You run the whole populations throughout the countries. No more samples. Okay, no more samples. You don't have sample size. You go populations. These are research methodology, not PLS. This is a research method, but it correlates with what type of analysis that you actually engage in. So that's what PLS will be the good one, will be the ideal one. So many of you are doing consumer research, for example. Your respondents are millions because they are consumers. Then you have to abide the sample size. You have populations of millions. It's impossible for you to get hooked with every one of them, isn't it? And that's the reason why research says you have to have a sample of your populations to represent them. So under the populations on your consumers, you also have to define your consumer. Who are your target respondent? Students, adults, with children, married, whatever. It all depends on your reading under your research. You see? And because of the nature of your studies like that, you cannot say that, okay, I use this because I can even have 100 sample size. No, it's wrong already. It's wrong. Okay, it's wrong. You don't use statistics to make your research easy. That's wrong. So there's two different here. Statistics versus theory. Statistics versus methodology. Now, you don't use statistics on your advantage just because of you want to cut it short. No, you can't do that. Especially those PhD students. It's a potential failure if you engage into that kind of path. It is a failure because you are not representing thoroughly enough your population. Okay? That is methodologies, research methodologies. You need to know that. Right? Clear? Any questions? Any questions so far? Now it's almost 11 o'clock. Any questions? Okay? Not okay? No response.
Okay, Doctor.
Okay. You need to talk. Because if there is no response, then how do I know that you're okay? So you gotta speak. You gotta speak up. Okay. You need to interact with me a bit. All right. So I cover those that not say they're all relevant. What I'm saying is that it's there are some students, especially even though we have been sharing this many times, we still have some students say, okay, I use PLS because it allow me to have a small sample size. No, cannot. That's wrong. It is not like that. That's the reason why I give you an example of the sample and populations. There are some studies, actually, it's very difficult for you to get your samples size due to, there are some constraints now, okay, that you will just not be able to get enough sample due to XYZ. Okay, we allow you. But in the first place, why do you actually embark the studies when you aware collecting the data is very difficult? So you actually, You're committing suicide actually. All right. So you got to be smart as well. You got to be smart. You must be smart enough to make the journey of your research, you know, accessible, reachable. Okay, something that can be complete. You don't do a research that you don't know you can complete or can't complete. No, you don't do that. If it's very difficult for you to get your data because of X, then why the first place you choose? There are some students even says that, well, I don't have that much money because that's the reason why I can't travel. No, that is not, should not be your limitation of your studies. No, you can't. You cannot use the excuse that, well, I'm doing MBA and then MBA period is just only like 3 months and that's therefore I can't collect more data. Well, the first place, why you choose that kind of topics? Let's say, so you got to be smart. Let's say, you have to be smart. PLS is all free, okay? There are some students, okay? PLS are free. Here, there's a student versions free, but only up to 100 respondents, okay? The professional versions, you gotta pay. It's quite expensive, but you gotta pay. I nowadays don't use PLS, I use MS. MS I got free. Anybody wants to use MS, I can install that in your computers. It's free of charge if you want MS, but you need to engage with MS. Okay, so there you go. Okay, no more excuse on the sample size. Why you actually using what? Another one that the advantage of if you again using PLS is a non-parametric approach, hence does not require normal distributed input data. Okay, there's another one that you will be very careful. Okay, especially the PhD student. Again, I specifically MBA, MSCM, we usually we give and takes lah, huh? We give and takes, but PhD and bio research, no, there's no pushover. I can straight away tell you, your data has to be clean. Okay, you need to clean. You need to make an effort to make the distribution of your data as normal as possible. You definitely will not get it normal. I can assure you it's very, very difficult because we are social science. Okay, many of our items are unobservable items. Sometimes it's not an absolute figure, 1, 2, 3. No, it's required feelings. It's your gut feeling. So we test them using Likert scale. Your propensities. Where do you actually, most likely you probably, or so that's the reason why we have this Likert scale. Many of us using Likert scale. Most likely or extremely yes, less, something like that. So we can't quantify them in an absolute value. You see, so that's the reason that we almost will not get normally distributed data. But there are remedies to make your data as to make it good to a normally distributed data using SPSS. Then only you can get a good model fit if you're using MS. CBSAM. If you are CBSAM is a parametric. You need to be normally distributed. You won't get, but if you generate your log, that is a separate methods. I'm not going to touch on that things, but it requires lots of exercise to make your data normally distributed. Okay, so that's a good thing. Again, not because that you don't have to do this, that's the reason why you choose PLS, and now you must follow. So if you fall under here, then only then you're good enough lah. Okay, And another thing good about PLS is that it can actually run a very complex model like this. You see, if you are using SAM covariance one, most likely you will not get model fit. It's very difficult to get a model fit if you have a very complex models. Very difficult. But SAM PLS, yes, you more likely can get it. Okay, so there's an advantage using PLS. And the rest. Okay, and PLS is especially useful for prediction. PLS is a very, very powerful tool. As far as I know, is a very powerful tool to make prediction. Okay, if you are make predictions, you want to know the influence of the latent variable. We call it latent variable, but it still can, dependent variables. Okay, how much variance, okay, weighted variance that to the dependent variable, PLS is a very good one. Okay, it's a very good one. So there you go. Which one is more suitable? If you make prediction, use this. If you're theory testing, using CBSAM. All right. If you are in PhD, you can actually use CB because you have time. Because you do have time. The MBA MHCM use PLS lah. I can straight away tell you. Unless you like to play with this gadget, then you can try MS. But MS or Listerel, these are CBSAM. There is a potential that your data may not be good enough. In other words, down here, you stuck in CFA, confirmatory factor analysis. Okay. Now what's down here is you're stuck here. You're stuck here. Here, the model is not fit. Okay. Of course, there's lots of parameters, values that you need to meet the minimum thresholds to get a model fit. Your RMSEs, okay, your CFI, all this stuff like. Okay, I'm not going to touch on that things, but you need to meet the minimum threshold of values. Then only you get a model fit. When you get a model fit, then only you can test your research model, your structural models. Then only you can test them. Then only you can test them like this. If you don't meet, no. Okay. In PLS, same thing, but PLS less rigid compared to CB form. Now what it's down here is you still have to get a model fit of your measurement models. Okay, these are your measurement models. All here. Yeah. Yeah. This one and this one, except these three in the middle. All the outer layers, we call it measurement models. This one, these are measurement models. These are measurement models. You need to get a model fit of this. The model fit that you need to, the parameters of model fit that you need to, what is your, these are the one, these two. Convergent validity, factor loading. Factor loading here has to be 0.7 and above. Okay. And 7. Then you have the AVE, average variance explained or extracted. FEE 0.50. Reliabilities, you have the composite reliability CR has to be 0.7 and higher, and your alpha, your combo alpha, okay, alpha value has to be 0.7, 0.6 should be okay, all this, and then you have the discriminant validity. All these measurement models, we do it next week. Okay, we do it next week. These all you need to meet the minimum thresholds. Then only you go to the next step, the testing the structural models. So you need to do all this. In other words, down here is it's like this. These are the measurement models. Okay, so you can see it here. Here is all the factor loadings. Okay, here is all the R square. These are all R square. Okay, but these are then of course the input. If you use the PLS, we'll be able to generate the AVE and the factor loadings. Okay, those lower factor loadings you can see if you can see 1, 2, 4, 6, right? You can see. So there's a missing number. Number 3 not there. Number 5 is not there, isn't it? Hello. Are you all with me now?
Yes.
Yeah, good.
You see, if you see the missing numbers here, meaning that I have already deleted them to make the threshold value so that I'll be able to get the minimum threshold values here. Factor loadings 0.7, AV 0.5, CR 0.7, alpha 0.7. All these values you need to make tables. You put it that in your thesis. And then the discriminant validities. Okay, basically what they are telling convergent validity here is basically what if you from the words convergent. Okay, it's a construct validity. Construct is this is the construct. See, convergent is to ensure all these items they converge represent this. Okay, where else? Discriminant validity, okay, it shows to you all these items are not supposed to belong under here. So the numbers of the loading should be higher than the square value of AVE. We'll show you the calculations next week. Here, just introductions. So same thing all here. So you can easily see all those numbers here. They're all very high. Some is 0.9, 0.6, and so on and so on. All right, and then some are only left 2. Here got few more actually. Okay, but they're all gone already because I already deleted them because they have a very low factor loadings values. Any values that is less than 0.3, 0.4, you throw them out. You delete them and then you run it again. Okay, then you run it again until you are able to get the values that above the threshold values, acceptable. Okay, then only your models good enough, fit enough to run the structural model. These are the structural model. You only need here. Okay. These are my structure. Okay. See, if you look at here, the linear one is this is the first hypothesis, the linear one. Linear one, this one, and this one only. we throw them out. This one don't have. This one don't have. Only here and here. Here represent here. This one represent here. Only this linear. But when you put it in your thesis, you put a research model here. It looks very simple, isn't it? Concept development innovations, very simple because we don't show the items, indicators here. These are linear, simple. Only one simple regression, only from X to Y. Very simple. Then when we goes to the non-linear, and these are very complex. See, when you put that in you simplify them, it looks very neat. But when you actually put them in PLS, it looks very messy. You see? And you can run them simultaneously at one time. Because in reality, when you actually develop products, you actually influenced by several factors simultaneously. You need to consider them at the same time. That's how human think. You don't think just using one variable to make up your decision. You need to consider other factors as well, and then you become a good manager, a good director. You see, if you are only make decision based on one factors, more likely the strategy or your decision may not be the good one. That's what they are saying. So in business research, social science research, what they are telling you is that the analysis of the factors has to be concurrently run or test. And that is the reason why SAM developed. You see? That is what. You see? And that's the reason why when you actually using, there are quite a number of directors, companies are actually engaged with, like us, academicians, professors, to help them to do some research and then to run and using statistics, okay, so that the statistic guide them in their decision making. You see, and basically what the MBA, MHCM, okay, what we have been telling you, all those subjects that you've gone through from your first semester, second semesters, are all about this. Your OBs, your marketings, okay, your managements, okay, they tell you these are the theories that actually play some parts, influence companies in their decision making. Some of those decisions are still hanging, and that's the reason why we want you to go and do some research. You see? So hopefully that you can generate some possible answer and something like that. You see? And this is the reason why we require you to run them simultaneously. All right? Then this is how you design them. You make the flow of your research models in a simplified manner. Okay? In a simple manner. You simplify them as simple as possible, and then the reader will understand much better. Okay, we put it. See, if you have like this, we already know that Okay, these are mediators. It mediates, and then we can put the your hypothesis 2A and hypothesis 2B. And when you actually run them, these are the moderators. In PLS, okay, next week I will show it to you. You need to set in the PLS smart. We use smart PLS, like you set them, and then you can see this is the moderator. Although you also see a moderator here, but these are the interactive effect: innovation, orientation, and EFF. You see, these are EFF. Okay. See? See, these are the moderator. This one, it's automatically generated by itself by the smart PLS. So these are the moderator. We are saying that see, it moderates the relationship between innovation and concept development. So when you actually test them, okay, so you can see there is extract here. Extract, a symbol, a sign of extract here. That is the interactive effect. And then you have the negative beta value, 0.672. 0.672. Mana itu Saleh Wahab? Saleh.
Ya, yes doktor. Assalamualaikum.
Ini
Salam
dokter
Majid
dalam.
Mifli.
Ini dokter juga ini. Ini dokter juga ini. Dia baru grad juga. Okay.
Alhamdulillah.
So he should know this thing. So when you see there's a negative 0.672, what does that mean?
Oh ya.
Apa maksudnya?
Ini mata dia berapa nampak doktor?
I'm
using the handphone. Siapa?
Ini adalah environmental effect. Environmental, that is, consists of market uncertainty, technology, and food trends. And then you moderate the relationship between innovation orientations to product development, concept development. And then you have a negative beta value of 0.672. You have a negative beta value. Beta value in smart PLS, we call it path coefficient also. Some article, they call it path coefficient or coefficient value or beta value. So when you have a negative 0.672, what does that mean? Apa maksud dia? Biasanya bila kita dapat nilai negatif, apa maksud dia? Dia ada maksud di dalam belakang dia tu. Dia when we actually put that in under discussion, there is a meaning, there's a reason behind why the value become negative. Dr. Saleh Wahab.
So far no idea doktor. Because for my case I don't have
tidak ada moderator. Okay. So contoh
I'm using the mediator.
Okay, contoh dia saya bagi tahu contoh dia. Ini adalah dia punya bapa dia adalah ini construct. Kita punya participant ni ada international student ke? Macam ada Chinese kan? Sometimes I tend to speak Malay. So when you actually interpret, okay, the result here, these are the main construct. This construct consists of 3 dimensions. Okay. Faham? Boleh Boleh? Boleh tangkap kah? Boleh tangkap? So, these are the main construct and consist of 3 dimensions. Okay? And we know that even though if it's a negative, I mean, I know lah, I mean, I'm not sure about you, but it's just to share with you because we are towards the end already. This, ini, the interactive, we do it next week, okay, with PLS, smart PLS software. But just to give you some ideas, okay, by looking at the beta value, I know this is already significant. I know it, 0.672, okay, but it's a negative. Okay, and by looking at the dimension here, we know that the one that very high beta value is food trend. That is 0.926. It's a positive. And then the second one is the highest one is 0.64. This is the value. This is a beta value. I don't have to bootstrap to get the t value. I also already know that it's significant. So I can conclude that technology doesn't play a negative effect to this relationship, to moderate the relationship, but I know the one the most is food trend. So innovation orientation here, if you want to generate innovative products, food trend mengacau innovation, pengamal innovation di restoran. Sebab food trend juga boleh menyebabkan product development successful. Itu sebab dia tinggi dan dia ada negatif di sini. And market uncertainty juga mempengaruhi, there's a negative, moderate the relationship. Itu maksudnya di sini. You see? So, it's quite clear that if you actually using this for complex one, you can actually be able to see the patterns. You see? You see the patterns. And theoretically, it makes sense. You see? So you can using that LS to test. Okay, so but I don't, for the MBA and MHCM, I don't expect you to do this now. I don't expect you to do this. Okay, if you do the nonlinear moderators, you should be careful. See, Dr. Saleh, okay, he actually using this on mediator. Pun sudah cukup untuk PhD level. Okay, nonlinear. But generally speaking, if you're doing a PhD or bioresearch, if you just do linear simple one, tidak boleh lah. It's not sufficient enough if you are doing PhD. Okay. But MBA, ini pun boleh. MBA. MHCM, many of them actually use this. Okay, so it looks very simple, isn't it? But when I show it to you, these are the structural model. Linear. Okay. So it should be good enough. For MBA also should be good enough. Sometimes your dependent variable, you may not have a multiple dimension. You only have just single construct. And straight away it's something like this. Then here probably you have 2, 3 independent variables, pointing arrow. So here we only have one hypothesis. But if you have 2-3 factors not correlated, but you predict influence your DV, you have 3 hypotheses. Okay? Boleh?
Boleh.
Okay. This, and then you have this mediators here. Okay. Mediators, if you're using PLS, okay, you can run them individually, then only you add this. In other words, down here, you run this one first, then only you add in the mediator. Then you'll be able to see what will be the values. These are all time. You can use them SPSS under the Pritchard and Hayes are much easier. Okay, there are some. But if you are using MS, MS allow you to test mediator in the software itself. You see? And when you actually combine them to become a complex, you become like this. It can be tested. Okay, can be tested. Like this. Right? So the first step, once you test the measurement models to ensure that the model are fit based on these parameters, then we goes to the testing structural model. The testing structural model, the one that I showed to you, all this 1, 2, 3, 4. Okay, and these are just an examples. What it needs to report is to look at the R square. Okay, R square is very important. We want to ensure that your explained variance of the dependent variables are, of course, there are 3 categories, minimals, medians, and substantials. There's some values. Even if you get lower R square values, not necessarily that your studies are no good or your research model are not good. Not necessarily. All depends on your models. Say, for example, that you have only one dimension here, pointing to your DV. This is your DV. Okay. Linear 1. Here, underneath, if you have 1.85. This is your R square. R square is very low. Only 18.5% explained. 18 point, not even 20% explained. This variable goes to here, only less than 20%. It's still acceptable. Okay, under chin, okay, it is a small explained, but it's still acceptable because it is understood because it's only one. Only one. And when I plug in another, say here, we have one, but I add in, and then there's another one moderator. Look at the R square value underneath here. It should to 50% explained variance. You see? All right. Of course, this will for those who maybe have no idea what I'm talking about when it comes to what is R square, what is the value, and so on. It should be okay. Don't worry. Eventually, when you come to that stage of methodology, you will know this. Just take some notes, okay? Get some idea what is it about, okay? Then if you read some of my yeah, yeah. You'll be able to have some idea what is it about. Okay, these are very good. I mean, these are all one, but they are the pioneer one. They tell you what is it about regression-based approach. Okay, I know they are quite technical, but they give you some idea what is it about. And of course, some of you already, maybe some of you do some reading already all about what is R square and so on. Okay, eventually you get to know that. Okay, that is R square. The next one is the effect size. These are many students, okay, based on my experience, especially MBA, MSCM students, many of them, they don't do the effect size, the F square. I don't know why. If the F square is good when it comes to, say for examples, make predictions of, okay, earlier I was talking about these mediators, moderators, okay? You can actually test, I mean, from the beta value, so I know this is the substantial one, but it is good that you actually run the effect size, the F square, okay? It will look nice in your thesis. It will look nice. It will look that the examiner, when they read, they see that you have done good analysis. You already have the analysis here. I mean, based on the beta value and so on. But do you reconfirm it again using the F square to indicate that the food trend, it has a very substantial effect size, mediating the relationship between innovations to concept development? That is what it's about. You reconfirm them, and it will look nice because there's a very nice statistic in the equations you put in your thesis, and it will look impressive. You have done your part. I mean, there's some minimal, not very complex calculations, but it can be done using simple calculators. And you calculate and then put that in your thesis. For MBA, MHCM student, if you put it like this, you feel great, man. I tell you. And your supervisor also feel great, and your examiner also will see that you have done your part. You reconfirm it back. And of course, we have few more. Okay. Yeah, the bootstrapping. Okay. Well, this one it was. Of course, well, Q tests. Okay, there's another Q to ensure that your model is acceptable. Model I didn't put it up here, but we will test that also later, and the model, because the PLS, the new PLS version 3 and above, okay, there are quite a few features that actually you can actually make the prediction much better, the model fit much better, which we'll talk that in the non-linear in 2 weeks from now. Because this is 3 series, we have intermediate. Next week, we're going to cover all this kind of testing. One by one. Okay, all this. and then we will show it to you how do you actually report that in your thesis. Okay, and then slowly by a bit hopefully it will give you some idea how you actually run your PLS, how do you actually make your report in all those figures, the values in the tables. You create the tables. All right. Any questions? Questions? Any questions? No questions? Come on. I'm sure you do. Mana ada tidak ada questions? Just to remind you guys, for those, I mean, there are quite a few PhD students. It sounds simple. It looks simple. But if your theory are not, I mean, your research models, if your research models are not confined to existing theories or theories that actually hold your structural model, it can be very risky, I tell you. Okay, that's one thing. Even if you be able to generate your measurement models, you'll be able to generate the minimum threshold. Because here, these are 1, 2, 3, 4, 6, 7. You can actually make it this model fit by throwing some of the items here or to manipulate. You can do some adjustment. You still can get the these parameters. But when it comes to your structural model testing, if your theory are not strong enough, you may not get what result that you expected. And it can be very, very scary when you are not get the result what you're supposed to get. Especially significant. If it's not significant, then you it is statistic. You see? So you gotta be very, especially the PhD and bioresearch, the theory base must be very, very strong. It has to be very strong. Because oftentimes PhD student, you can't just copy or adapt existing construct or measurement model from, you need to contribute. MBA, MHCM, okay, I will still accept you guys adopt existing studies. Okay, the research model of existing studies. We still can accept you. Maybe you test them in a different location. We still can accept that because due to the fact that you don't have time, the time is kind of short. But for masters by research and PhD, there is no excuse to that. You need to be very, very careful. There must be an element of newness. And that new stuff that you bring in, or you eventually you will call it, you brought in your thesis, okay, will be your contribution, your study contributions to knowledge, contributions to the industries, you see, or extensions to existing knowledge. Most likely extensions, I mean, unless you are professors, probably you create a new theory. Even professors also hardly create new theory nowadays. You see? Yeah, that's about it now. Okay. Like I said, it's not difficult. Okay, and the new versions of PLS, it's easily can be downloaded. Okay, the professional one you have to pay lah, but there's a trial there. So for those who actually already collect data and so on, maybe when you collect data, when you do your pilot, you're using a student trial version. And when you actually come to the stage that you actually wants to run your actual data already, there's a trial up for a month. You can use that to maximize of that free trial. You can run as much as, I mean, you run within a month, every day, every night, and so on, and then make sure you save that, and it become your data. You save them so that you can always extract them back. Once you delete them, when you run again, remember when you run PLS, the value will be different. Anybody knows why? Why the value different? Just using bootstrapping. Okay, so they're bound to have some changes, but not dramatic, not huge. You will be still within that acceptable values. Okay, from the first one that you being generated or the second one, but you will not be able to get the exact number, because once you deleted them, then you bootstrap again, you test that again, the value of your beta value and your t value will be different. But the t value usually we report them the full number figures, but usually t value will based on your p value already, whether it's 99% confidence level, 95 or 90. Okay, so p equal or greater than 1.01 or 0.05.1. But the real value, it is still good to report that in your tables. You see, so when you actually get the trial version, they give you a month. Make sure you save. Once you save them, it will be in your file. It will not disappear. It will always be there. Okay, so you can. It should be okay. Anything else? Anything that you're afraid? Anything? Anybody? Any PhD students have already come to the stage of analyzing your data? Not yet. Any PhD students? Master students? No. And sure, no question. Was so good. No questions.
Yeah, Doctor. Just
Okay.
wondering, have you checked the chat box, Doctor? I noticed there's a lot of question from the student
Okay.
chat box.
I did not. Elizabeth, can I record nih kan Elizabeth?
Yeah.
Okay, wait. Let me check.
Ya, dokter.
Cek, ada record bang?
Ya, ada.
Okay. Alright. Let me see the chat one. See what the... Okay. There's a cause and effect. Okay. There's another word, a causal or not, causal or non-causal. Okay. Causal, non-causal. The causal interactive will touch that in 2 weeks from now. The non-linear. Okay. Causal one is okay. There are variables that cause the original relationship to change or no effect. Okay, we'll talk that thing. Okay, there's another one. Is it time limit should be the construct and why one are the indicators? Yes, they are indicators. Okay, another one is the PLS tool to analyze models or to determine the indicator relation with the construct or not. Or yes, indicators and constructs. Okay, basically, indicator are your questionnaires. Okay, NBA, MHCM, we generally accept if you adopt existing scale measure, a measure that has been validated. When I say validated here, the data has been performed EFA, factor analysis. Okay, I did not touch factor analysis. I did touch a little bit, but never actually because that is SPSS side, EFA. Okay, what is that? EFA means here, all these items, these are questionnaires, these are indicators. These are indicators. These are indicators. I lump all these indicators in factor analysis. Okay, we call it EFA, under principal component analysis. I take principal component analysis because I do not know the theory first. But of course, in reality, I already know there are several stages under concept development. So I developed the questionnaire. I put all these items into factor analysis. This one I don't know. I don't know whether it's 4, 5, 6, I don't know. This one never exists. It's non-exists. Only this. So I put it there. And then I run. Factor analysis output came out several components. Some of the components, okay, of course, I manipulate a little bit of it, and then eventually it becomes 4 components. Okay, all this I need to test to ensure that they're all, the validity are correct, reliability are correct. These are before PLS. These are before PLS. PhD, master by research, you have to do this. You must do. MBA, MHCM, for those who decided to do on your own, yes, you have to do factor analysis. But I can generally say most of you don't have to do factor analysis because you are actually adopting existing scale measure from someone else that has already been validated. Validated meaning the one that I just explained to you, this one, has already been performed, factorized, dia punya factor. Sudah kena, ada dia punya belongs to, this questionnaire belong here. You already know that. You don't do on your own. You don't do your own. Especially the PhD and master by research. You don't never manipulate your questionnaire because obviously many of you get your questionnaire from your reading literature. Or you ambil sini, or ini under this construct. Okay. Then you put it there. And then you make assumptions that it's already been validated. Then you run Cronbach alpha. Wow. 0.6, 0.7. Okay. If you're lucky, you will stay that way. Then you go to final data collection. Usually when factor analysis, we don't, the data are not actual data, it's the pilot data. In other words, you have to collect 2 data collection. You can also use final data, but you need to divide them into two. These are for PhD and master by research. MBA, I mean, you still apply, but this is more specifically for the PhD. Okay, you must run pilot data, collect pilot data. The pilot data you can collect up to, depending on the number of questionnaires that you have. If you get somewhere around 50 or 100, as long as you do not exhaust your sample, meaning that you have quite a number. Say for your consumer, hey, run, get as many as possible. I mean, you don't have to run until 200-300, no need, no. Okay, if you get 100, good enough to run a pilot data, hey, run. Then the pilot data, you'll be able to generate the component. You see, they're bound to have some deletions of questionnaire. You must. It's almost certain. I'm not saying 100%, but almost certain that you will delete some questionnaire because your inter-item consistent correlations. Basically, it's a correlation. Factor analysis is a correlation. You see, your inter-item between one item to one items, okay, they're bound to have some item are not belongs to that component, and you need to throw them out. Then you get a good indicators that rightfully belongs to that particular variables. All right. Okay, so yes, indicators, yes. This one from Muhammad Razali alias. Okay, so yes, indicators supposed to be the scale measure of that dimension or construct. Has to. Okay. Can PLS support panel data? Yes, of course it can. Okay. But again, if you have usually panel data is okay. If you come from the econometrics econ side, it is good that you talk with your supervisor. Should I use this, or should you go more on the common software or measurements that generally used to measure panel data, like Pgws, something like that. Okay. Now I have a free PLS, doctor, or must buy. Yeah, PLS is free. Okay. Long time ago we get it the PLS 2. It's still available, but no longer supported. But you can download, and they will give you the key numbers, and you can put insert there any product key for PLS. Just one. Now, as far as mine, last time me and Dr. Jude, we conduct PLS. Not sure. I need to ask Dr. Jude whether he has or not, but I think we all finished already. All the product keys have been used, gone. But again, like I said to you, you can always get the free version, one student version, and then get the free trial one. Okay. Yeah, Dr. Lim already says it's a free one. It's only 100. Okay, that's yeah. So you buy, but you can get the premium version one for 1 month use free. Any student offer free if you truly read it. Yeah, that's the one that I if you're ready, you can. ATM Care, they have the SPSS. Mine is version 22. Even though I use as version 22, I'm still it still has extension of partial least square. Next week, I will show you 2 versions using Smart PLS and using SPSS partially squared. Okay, but SPSS, your measurement model must be all good first lah before we run the structural model. Okay, but it can be done. It can be done. Not friendly lah. SPSS, PLS not friendly. You need to have someone to guide you lah. Okay, but PLS, smart PLS is very easy. Okay, it should be okay. It should be okay. You just for version 1, you just key in smart PLS. There, Dr. Lim already says smart PLS website. You just follow the step. It's very easy. It's there. Okay. Another one good, Muhammad Alif. Is it possible to have one indicator for one construct? Initially 3, but you run out after you omit 1. Okay. Advisably, no, because once you only have one indicator, then your factor will become absolute 1. Then not advisable. Okay, I'm not saying, I mean, Hayes books, okay, in 2014 or 2015, it allow you to have 1. But maybe I think Alif is doing a PhD. My advice is don't gamble. We never know. Nowadays, many examiners are already quite well versed in PLS, so they may question you more. Why at the first place? If you have 3 indicators, why you develop three questionnaires for your construct or for your dimension? If you are developing 1, if you are adopting, then there's the question. So my advice to all the students is to ensure that all your indicators or your questionnaires, you have more. So once you do the cleansings during your measurement models, testing, those factor loadings that have a very low values, you need to throw them out. Okay, at least you still have at least 3, minimum 3, 2. Okay, if you 1, not as possible. Okay. Okay, that's it. Any more questions? Yeah, Sylvester, yes. Next week, Sylvester, we my experience with my MBA students, even my PhD students are using PLS. I have to do it slowly. Cannot be one time. One time, I don't think you can catch up. So slowly, because through online. If not because the MCO, we have 1 full day, we have a break and so on, that should be okay. Okay, 2 day, 1 day course, okay, we should be able. And then everybody have a computers. So make sure next week that you have installed your PLS in your computers. All right. If you have 2 computers, advisable to just use 2 computers because we can do some simulations. Yeah. Yeah, so I have 2 computers. If you have 2 laptops, you can just put it side to side, and then you can do some. You can follow simulations. Generally, if you are still not analyzing you still a long way to analyze your data. You just many of you will not do the simulations, but that's my job now, just to show it to you whether you follow or not follow. I'm okay. Okay, but I just try to help the students. This is a simulation, and then hopefully it will help you guys lah. Okay. A simple one, simple one. We'll do the measurement models. Then we do the normal regressions. Okay, the mediators and moderators. Okay, we'll talk on the next week. Okay. Right. Any questions? Any more? Any? If there is. No? Okay, if don't have, then I think that's it. Thank you for being with me for about 2 hours now. Anything, you can always email to me, okay? Maybe some of you, you do know my emails. Okay, so you can always email. All right. If nothing, then thank you lah so much.